Okay, this is the touchscreen display. It's one of the Victron GX controllers. This is the graphical control unit that you would use in place of a digital multi-control, which only controls the inverter. It has the switch and the current limit knob that allows you to see the status of the inverter, turn it on or off, or charge only, and then set the current limit. That's all that a digital control does, and then you're separately using the BMV712 or the display panel. If you have the VE Bus Smart adapter, it also allows you to, through the same phone app that you can see the BMV, also allows you to see the inverter status as well as, and also change it if you don't have the digital control. So you either need the VE Bus Bluetooth interface to the phone app, the digital multi-control module, which only controls the inverter, and then the other three options are the GX line. The color control, which has a similar display to this, except it has buttons underneath it and it is not a touchscreen. Very difficult to install because it requires a strange hole in the wall, a very large hole in the wall, difficult to install in Travato, I should say. The Venus is the same kind of control head as a Servo, except that the Venus doesn't have a display. You have to use your phone, and you have to have some other networking gear to get from the phone's Wi-Fi through to the Venus control. You either plug in a USB Wi-Fi or plug Ethernet through some kind of network adapter, like a Wi-Fi router. So don't recommend the Venus. Can recommend this top of the line Cerbo, as it has a lot of fancy features. I'm going to go through that relatively quickly here for you. The top line, and again, this is the same display that's on a color control, but the Cerbo is easier to install, although it is pricier, but it has a better interface and more things that you can control with it. This top line here across the top is your 120 volt AC devices. So shore power in, it's automatically the generator through the ATS if the generator is running, the inverter itself, and then the output from the inverter feeding your breaker panel. So anything, like right now I've got the air conditioner running, so that's your 1400 watts of AC load happening there. And then the battery, in this case I've got a smart shunt meter as opposed to the BMV712, either one works. It is showing that I have 100% battery power. The other DC loads that are attached in parallel to the battery, such as your lights and whatnot, those are actually, it shows it kind of looping through the battery, but in fact the battery is at 0 amps. So there's no power coming in out of the battery right now. It's basically, we're pulling the battery to run, the power to run the lights in here right now is actually coming from the solar. So I've got lots of hot sun, it's hot outside, I've got the air conditioner running, which you can see here from the shore panel, and I've got 88 watts of power. There's actually more power available. I've got 500 some watts of solar panels on the roof. But I'm only using 88 watts. That's all it's able to show right now, because that's power is coming from that power. That 87 watts is what's running my lights and everything else in here that's running on 12 volts DC. So right now my shore input is going directly through the inverter and is going to the output. The inverter is not actually providing any power to charge the batteries right now because it doesn't need to. The battery is full and the solar is taking up all of the other DC load. Now let's say what would happen here. What actually I need to go over real quick is if you touch this, you get the menu pop up here. You can switch between different display pages. This one allows you to manually run the generator, gives you the generator status. Also, the Cerbo has the ability to hook up to sea-level tank sensors. These are ones, instead of a thirds of tank, this gives you full 100% level, 0 to 100% level of your tank. So it's an additional sensor that has to be added. I haven't added mine yet. I'm going to, but I've got the first tank sensor turned on, just so you can see that that's an option. So if I go into the menu, I can then see I've got my tank sensor, my inverter. I'm going to go into the inverter. You can see here that I have all of the detailed information, more so than on the display panel. It'll show me the exact volts and current coming in, and the exact volts and current, and the frequency going out. So you can see I'm pulling in 12 something amps, and that's what's going to run the air conditioner right now. Up here you can see I've got the inverter set to on, so fully on, and I've got the current limit set at 30, because right now I'm plugged into a 30 amp shore connection. Now let's say that I wasn't plugged into a 30 amp, I'm plugged into a 10 amp. So if I turn this down to 10, there we go, and push the check mark. And what happens now is the inverter goes into assisting mode. Now if I go back to the display panel, you see a different picture. And that's what's so great about this graphical display. It's showing that I'm only pulling 1,000 watts from shore because I've turned my current limit down to 10. So it's actually only pulling about 9. It usually runs about 1 amp less than what you set it for. So it won't blow a 10 amp or a 15 amp or whatever you set it for, the breaker that's there. Now I set it to 10 on low on purpose so I can show you the assist mode of the inverter. Now this is standard with the inverter, but you can see how easy it is to see what's really happening with this graphical display, which is what makes the the Cerbo and the touchscreen so great. It's showing me that I'm in the assist mode, which means I've only got 1,000 watts of shore power coming in. I've got 1,400 watts going out to the air conditioner still. And I'm pulling the extra 300 watts from the batteries. I'm also now pulling a little bit more watts from the solar panel too. So the solar panels are actually helping out. Actually, sorry, the 1,500 minus the 10 something is actually more like a difference of 400 or 500. That's the almost 400 coming out of the batteries, but I'm also have 100 watts still going into lights and whatnot running, and I've got the extra coming from the solar. So this is showing you how everything is working together. The solar input is coming in, the battery is providing power. This is what's going into the inverter and generating the extra power necessary to run that. If I go back into the menu and look at the inverter details, I can see here how I've got 9, basically it's going up and down a little bit, but basically I'm pulling 9 amps, 1 amp less than what I set the current limit to, but I'm supplying 12 point something amps to the AC systems. In this case, 99% of that is the air conditioner that's running. And you can see the same watts numbers. It only shows me the watts on the main display to avoid confusion. But you can also then see, if I scroll up here, the inverter is now taking negative current. It's taking from the battery 30 amps some in order to operate the inverter to provide that extra 400 or 500 watts worth of power to run things. So if I then take this in current limit and set it back up to my 30 that I would normally do, and is what I'm currently plugged into, and then I go back to the graphical display, the situation changes, and now I'm charging. You can see the power flowing into the battery. I'm now charging the batteries, and 35, 40, so it's actually running the amps up slowly in order to recharge the battery. And you can see that I'm pulling quite a lot of power from shore, more so than what I'm sending to the air conditioner, because it's generating that DC power back in to charge the batteries. And you can see from the sun I'm getting right now, it looks like I would normally get about 246 watts or some from my solar panel right now. So that's the advantage if you do upgrade the ZAMP controller to the Victron MPPT. You've got the ability to see what your solar is doing, and because this DC power box is basically giving me what the power that is being provided or used by the inverter. mixes in with that the power coming in from the solar. It knows exactly what the power going in out of the batteries. Whatever's left over must be something that is in parallel with the batteries that is either taking or providing power. If I was running the chassis engine, I would actually see this as power coming in, which strangely enough shows up as a negative number, where I'm actually charging the batteries instead of taking that power from the battery. So the nice thing about this graphical display is it gives you full status display of everything in your system. I can adjust the inverter very easily on the menu. I can even go into the menu and look at what my solar, I can even look at the daily history, and I can see for each of the days what my power that I've gotten out of my solar system is. So I have that history data. I believe it keeps up to 30 days. And then, I can also in the menu look at the BMV information, the Smart Shot information, including some history on that, as well as the current state of charge and the actual details. And these are actually shown on the display panel. The other thing that is handy to know about this is that the Servo, in addition to the color control also, if you go into the settings, it has a relay output which you can use for generator start-stop. And I have the auto generator control module that I put in. This is something I've come up with myself and I make available. But it's really just a couple of relays that takes the relay output of, the Cerbo BMV 712 or the color controller, and it converts it into start and stop push button relays for turning the generator on and off. Now I've got this set, and you can also set in the settings of the generator start stop, you can also set quiet hours, so you can actually tell it what quiet hours are. I don't usually run with quiet hours, but then I can also come back up here and do, and I can do the conditions, and these are the conditions under which I'm going to start the generator automatically. I have the SOC levels set for 20% to start, 80% to stop. You don't want to try to charge it up to 100%. It takes forever to reach that last few percentage of charge. But anytime I get down to 20%, it will automatically close the relay to call for generator and then open it up again at 80% so that I don't have to worry about the battery running down. And there's all kinds of, in the color control as well as in the Servo, I have all of these ways of enabling or starting the generator for various conditions, including battery voltage. I have it turned on because my battery voltage goes too low. For example, if the battle-born batteries, if I've got the heat mode turned on, that can run the battery down and the voltage will come down, even though the SOC doesn't show it, because that power to run the heater on the batteries doesn't go through the shunt, so it doesn't know, the Victron system doesn't know about it. So I have the battery voltage turned on as a backup means of kicking on the inverter if I get low battery without the shunt tracking it properly, which would only happen if the heaters were turned on. And then I also have the ability to turn it on in over temperature on the inverter if it overloads the inverter. Also, I can turn it on based on load. So if I've got more than a certain wattage of load coming out of the system, I can turn on the generator for so much time. I can have it automatically turn on the generator. So like if I've been running the air conditioner for say more than an hour, which would take more than a certain amount of watts, I might want to just go ahead and kick on the generator anyway to catch it up. I know I'm not going to be able to keep it going all that long. So that's an option that you have with the Servo or color control, as well as I can do a periodic run. I can say for a certain duration, I want you to start at a particular time and do it on an every so many days basis. So this would be a way of running the generator every month for a couple of hours, other than you have the issue of how do you make sure that it's got a proper load on it. So that is a quick overview of what the advantage of either the color control, difficult to install, or the Cerbo, which is a separate little box that hides in behind a panel somewhere. You never have to see it again. And it has this lovely touch screen that works really well, better than the color control, I think. It is a little pricier, but it also gives you the ability to do the fancier tank level sensors if you want to go that route. It also has this display that is easy to mount. I mean, I've got it here mounted 2022 style over the sliding door. This is actually on a 14. But you can easily install this. Let's say that you were taking out the ZAMP to put in the the Victron MPP solar controller. You could easily put a piece of wood or plastic. I'll eventually have some adapter rings available. So you could mount this over the hole that was left by the ZAMP, or you could mount it in place of the PCS, because installing the Victron 3000 eliminates the need for the PCS. You want to disable the PCS system when you've installed the Victron 3000, because it has that assist mode that handles larger current output automatically without having to try to turn off the air conditioner. So there you have it. Fancy color display, available both on the color control, but then also with the nicer, easier to install separate display and box of the Cerbo system. It's two separate parts that you have to buy, the Cerbo box and the touch panel. I believe it's a GX50 is the part on Victron. This is significantly easier to install and can go anywhere, including over the door.